Welcome back, children. Now we can do problems based on conditional probability. So the first question, if P of A is equal to 0.8, P of B is 0.5, P of B given A is 0.4. Find P of A intersection B, P of A given B and P of A union B. So P of A is given, P of A is equal to 0.8, P of B is 0.5 and P of B given A is given. P of B given A is 0.4. What is P of B given A? By the definition we can write it is B intersection A. P of B intersection A by P of A. That is 0.4. Then P of A is given, which implies P of B intersection A is same as A intersection B. A intersection B by P of A. What is P of A? 0.8. That's equal to 0.4. So what is P of A intersection B? P of A intersection B is equal to 0.4 into 0.8. That is 0.32. That is P of A intersection B. That's the first one. Now the second one, P of A given B. So P of A given B. How we write P of A given B? P of A intersection B divided by P of B. A intersection B by P of B. What is A intersection B? 0.32 divided by P of B. P of B is 0.5. So you can multiply by 10. So it is 3.2 by 5. So 0.3624. So 0.64. Now the last one, P of A union B. What is P of A union B? Third one, P of A union B. P of A union B is P of A plus P of B minus P of A intersection B. Now substitute. P of A is 0.8 plus 0.5 minus 0. Intersection is 3. So add it, 0.8 plus 0.5 is 1.3. Okay, you know the decimal addition. Here 1, so it is 1.3 minus 0.32. Now subtract. They are not like decimals. So 1.3 I can write 30 and 0.32. Okay. So it is 9. So it is 0.98. Okay. Now the next one, evaluate P of A union B if 2 P of A is equal to P of B equal to 5 by 3 and P of A given B is 2 by 5. So we can write P of B is 5 by 13. Then 2 P of A is 5 by 13. So what is P of A? Therefore, P of A is 5 by 13 divided by 2, or it is 5 by 2 into 13, that is 5 by 26. So P of A, P of B. Now P of A given B is given. P of A given B is 2 by 5. What is P of A given B? P of A intersection B by P of B, that's equal to 2 by 5. So what is P of A intersection B. P of B is given now. P of B is 5 by 13. Okay. So 5 by 13 here is equal to 2 by 3. So which implies P of A given A intersection B is equal to 2 by 5 into 5 by 13. So it is 2 by, correct? So it is 2 by 30. Now what we have to find? P of A union B. So P of A union B is equal to P of A plus P of B minus P of A intersection B. So P of A, what is P of A? 5 by 26 plus P of B 5 by 13 minus 2 by 13. So LCM is 26, 5, then 10 minus 4, that is 11 by 26. Okay. The next one, a black and red dice are rolled. Find the conditional probability of obtaining a sum greater than 9 given that black die resulted in a 5. So, black and red dice are rolled, that is two dice rolled. What is the sample space? First we can write the sample space. The experiment is two dice are thrown. So, the sample space is, when two dice are thrown, sample space, there are 36 outcomes. It is 1, 1, 1, 1, 1, 2, like that, 1, 3, 1, 4, 1, 5, 1, 6. The next row, 2, 1, 2, 2, 2, 3, 2, 6, 3, 1, 3, 2, 4, 1, 4, 2, 5, 1, 5, 2. The last one, 6, 1, 6, 2, etc. 6, 6. This is the sample space. Okay, the first indicate black die, second one red, a black and red. So we take the first as black color, second one is red color. Now find the conditional probability of obtaining a sum greater than 9. So what we have to find, that you can take as E. That is, here to find the sum greater than 9. So we can define E as the event sum is greater than 9. That is the event E. Okay. Then what is given? Given that black die resulted in a 5. Given that you have to write as F. So F is the event. What is the event? Black die. Black means the first one. Black die resulted in 5. Okay. So you have to read the question, then define the event. It's important. Then what we have to find? The conditional probability of this E given that F. Okay. So it is P of E given F. This only we have to find in this question. Is it question clear? Probability of, find the probability of, conditional probability of obtaining a sum greater than 9. That should be in the numerator. Okay. Then given that, what is given that? That should be in the denominator. Now what is P of E given F? We know the result. P of E given F is P of E intersection F divided by P of F. So we have to find E intersection F. So what is E? Okay, here itself we can write as set. Okay, sum is greater than 9. Which all outcomes in this E? Sum is greater than 9. Sum is greater than 9 means I can write 6, 6. 6, 6 sum is 12. 6, 6 I can write. 6, 5 is 11. Then what about 6, 4? 6, 4 is 10. That's okay. 6, 3 I can't write since it is greater than 9. Okay, so from this 6th row, 3 outcomes. Then what about the 5th row? 5th row, the last element is 5, 6, that is 11. Then 5, 5 is 10. 5, 4 is 9, that we can't do. Sum means you have to add these two. So from the 5th row, only 2 outcomes. Then what about the 4th row? 4 and 6, the last element. 4, 5 is not possible. So this much outcomes in E. Now what is F? F is black die resulted in 5. Black means the first one. Black die resulted in 5 means the first element must be 5. So I can write 5, 1. That is 5th row. 5, 2, 5, 3, 5, 4, 5, 5, 5, 6. This is F. Okay. Now is there intersection? What is E intersection F? Any common element? Yes, 5, 6 is here. 5, 5 also. 5, 6 and 5, 5. Now find the probability, corresponding probability and substitute. So what is P of E intersection F? P of E given F is equal to P of E intersection F. So you have to take the number 1, 2. 2 out of what? 2 out of the sample space. How many elements in sample space? 36 elements are there. So 2 by 36. Then denominator is P of F. In F how many elements? 6 elements now. So 6 by 36. Okay. So you have to calculate what is the value. 2 by 36 by 6 by 36. So P of E given F is equal to 2 by 36 divided by 6 by 36. 36 and 36 cancel. 2 by 6 is equal to 1 by 3. So in this way you can calculate. Okay. Now the next one. A die is thrown 3 times. E be the event, 4 appears on the third toss. 3 dice are thrown, or no, a die is thrown 3 times. So triplet, you have to write as triplet. E means 4 appears on the third toss. So last number is 4. F means 6 and 5 appears respectively on the first 2 tosses. Determine P of E given F. So when a die is thrown 3 times, how many outcomes are there? When a die is thrown 1 time, 6 outcomes, 2 times 6 into 6, 36. So 3 times means 6 into 6 into 6, that is 216 outcomes are there. From that it is not possible to find. So we just write the sample space, you can put etc and write. Just write the how is the element, how is the outcome. The 3 numbers are there, triplet. As a triplet we have to write. The first one is 1, 1, 1. Okay. Then I can write 1, 1, 2. Then 1, 1, 3. Like that. 1, 1, 6. Clear? Now the second row, the middle one you can change. 1, 2, 1. 1, 2, 2. 1, 2, 3. Like 1, 2, 6. The next is 1, 3, 1, 1, 3, 2 like that. Then 1, 4, 1, 1, 4, 2, 1, 5, 1, 1, 5, 2, etc. etc. So the last row 1, 6, 1, 1, 6, 2, 1, 6, 3, 1, 6, 6. Okay. So in the first row there are 6 elements, only the last element changes. Okay. So 6, 6, 6 like that. This much is how many elements here? 36 outcomes. Now we can change this one. So starting with 2. Now 2, 1, 1. 2, 1, 2, like that, 2, 1, 6. Then second one you have to change 2, 2, 1, 2, 2, 2, like that, 2, 2, 6. Then the last row is 2, 6, 1, 2, 6, 2, 2, 6, 6. Okay. Here also 36 elements, 36 outcomes. Then etc. etc. The last. Then like that 3, first element 3, first element 4, first element 5. Then last is first element 6. So total how many are there? Total 216 are there. Okay. All these elements it is not possible to list. So 6, 1, 1, 6, 1, 2, etc. 6, 1, 6. Then 6, 2, 1, 6, 2, 2, 6, 2, 6. Then the last row, etc. 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 6, 6, 1, 6, 6, 2, etc. 6, 6, 6. Okay, so this is the pattern. So total 216 outcomes. Now, what is E and F? E means 4 appears on the third toss. So third number is 4. Third number is 4 means the next element 1, 1, 4. Okay. Here we have 1, 1, 4, 1, 2, 4, 1, 3, 4, like that 1, 6, 4. So just check it. 4 appears on the third toss. So 1, 1, 4, that is in the first row. Then 1, 2, 4, 1, 3, 4, like that 1, 6, 4. 4 in the last. Then this is from this 6 rows. Then starting with 2 again, 2, 1, 4, 2, 2, 4, etc. etc. 2, 6, 4. Okay. So here 6 outcomes, here also 6 outcomes. Then third starting with 3, 4, 5 and 6. 6, 1, 4, 6, 2, 4, etc. 6, 6, 4. So how many outcomes are there? There are 6 into 6, that is 36. So P of E is 36, but we don't want P of E. We have to find P of E intersection F. P of E intersection F is equal to P of, how we write P of E intersection F? P of E intersection, P of E given F is equal to P of E intersection F by P of F. Okay. So P of E that we don't want to find, I just say how to find that. Okay. Now what is E intersection F? Before that, what is F? 6 and 5 appears on the first 2 tosses. So 6 and 5 as first number. So which all elements will come? 6 and 5. That is, we can write and write last. So F means 6 and 5 in as first 2. So 6, 5, 1, 6, 5, 2, 6, 5, 3, like that. The last one 6, 5, 6. Only this much in F. The first 2 elements must be 6 and 5. So there are 6 elements in F. So P of F means 6. Out of what? Out of 216. That is total number of outcomes, which is the random experiment, that sample space, that element you have to take as denominator. Okay. Now what is E intersection F? E intersection F means F is 6 and 5 as the first 2 elements. E means 4 in the third toss. So their intersection means 6, 5, 4. Only this one. 6 and 5. F means 6 and 5 in the first place. E means 4 in the third place. So there is only one single element, only this element. So what is P of E intersection F? P of E intersection F is equal to 1 out of 260. So now we can substitute here 6 out of 216 by, 1 out of 216 by 6 out of 216. So that's equal to 1 by 6. Clear this one? A die is thrown 3 times, so total there are 216 outcomes. We have to find P of E given F. So it is P of E intersection F by P of F. F means 6 and 5 appears in the first 2 tosses. Okay, so first 2 elements 6 and 5. So when we check all these elements, F means the set of 6, 5, 1, 6, 5, 2, etc. 6, 5, 6. So there are only 6 elements in that set. Now E means 4 comes in the third toss. So third number as 4. Third number as 4, there are 36 elements are there. When we take intersection, you don't want to find E separately. As in the formula, it is P of E intersection F by P of F. So F you have to find, then E intersection F. In this case, it is difficult to write list E, that's why you don't want to write. Other cases you can write. So here E intersection F means 6, 5 in the first 2 places and 4 in the third place. So the number, so the element is only this one, 6, 5, 4. So probability is 1 out of 260. So when we divide, we get 1 by 6. Okay. Now the next one, a fair die is rolled. Consider the events E, F and G. Find 3 subdivisions are there. P of E given F and P of F given E. P of E given G and P of G given E. P of E union F given G and P of E intersection F given G. So a fair die is rolled. Fair die means how many outcomes are there? 1 to 6. 4, 5, 6. These are events. E, F, G are subsets of the sample space. That's why they are events. Now, the first one, P of E given F. P of E given F means P of E intersection F by P of F. So, we have to find what is E intersection F. So, in this side, what is E intersection F? E intersection F, common element only 1, 3. So what is the probability? 1 out of 6. P of F, in F 3 elements, so 3 out of 6, 2 elements, 2 out of 6, so it is 1 by 2. Now F given E, P of F given E, that is F given E means F intersection E, that is same as E intersection F by P of E. So it is 1 by 6 itself by P of E is 3 by 6. So it is 1 by 2. Okay. Now the second question. E given G. P of E given G. P of E given G means E intersection G by P of G. So what is E intersection G? E and G, that is 3 and 5. 3, 5. So the probability is 2 out of 6 by P of G, 4 out of 6. So it is 1 by 2. Second one is also 1 by 2. Now what is P of G given E? G given E means P of G intersection E by P of E. G intersection E is same as E intersection G, 2 by 6 by, in E 3. So it is 2 by 3. Okay. Now the third subdivision. Third subdivision. P of E union F given G. So what is the result? E union F given G is P of E given G plus P of F given G minus P of E intersection F given G. Okay. E given G, that is here, E given G is 1 by 2. F given G is here? No. So we have to find. Okay. What is P of F given G? P of F given G is equal to P of F intersection G by P of G. And F and G, what is the intersection? 2 and 3. Okay. So 2 elements, 2 out of 6 by G, 4 out of 6. So it is 1 by 2. So F given G is also 1 by 2 minus E intersection F given G. What is E intersection F? So again we have to find that P of E intersection F given G. That is P of E intersection F intersection G by P of G. What is the total intersection? E, F and G. Any common element? 3 is there. So only 3. So 1 out of 6 by 4 out of 6. So it is 1 by 4. So 1 minus 1 by 4, that's equal to 3 by 4. Okay. So that's equal to 3 by 4. Now the fourth one. Third question, the second part. What is P of E intersection F given G? That is this one. E intersection F intersection G by P of G. That is 1 by 6. 1 by 6 out of 4 by 6. That's equal to 1 by 4. Okay.